This talk is sponsored by The Graph. The Graph is a decentralized protocol for querying blockchain networks like Ethereum and IPFS. The Graph serves over 2 billion queries per day with thousands of subgraphs deployed for gaming, NFT, and DeFi Web3 applications. Learn more at thegraph.com.
Hello everyone, my name is Pirela, and I want to welcome everyone that's watching this conference right now and who will later watch the conference too. It is my great pleasure to be here at the Web3 conference, and I have to say it's amazing to see how as a community we're coming together in this kind of conference just to talk about our favorite technologies, to talk about our favorite networks, to talk about how to solve issues with applications in Web3, how to solve issues in a decentralized way. I cannot stress enough how amazing it is to see all this community growing in Web3 and how passionate people are working towards Web3 applications. It's really visible. It happens on Twitter, it happens in GitHub. You can see a lot of development being worked on regarding Web3, and it is really mind-blowing. And I think many of us here are here for that reason, because we're passionate about Web3 applications and solving issues in a decentralized and fair way. With that said, I want to thank the Web3 conference for having me today. And I also want to thank all the different speakers that we're going to have throughout the day and throughout the next few sessions, because we're all here for the same purpose and we're all here to talk about amazing things. So thanks everyone for watching, and thanks the staff that has made this possible, and I want to thank all the speakers as well. I'm going to be focusing on Arweave Verto 3M, and I'll talk later about it with some examples. I'll be sharing my screen and you all can see what I'm referring to. But first, a little bit of background. What is Arweave? Arweave is known as the permaweb, the permanent web. Arweave is a blockchain meant to store data, any kind of data. Just like Bitcoin is meant to store Bitcoin transactions, and Ethereum is meant to store a state of contracts and contract source code and Ethereum bytecode and execute those contracts, Arweave was meant to store data. And it was meant to store data in a way that's scalable and in a way that's cheap. Right now, as I'm speaking, it costs you $7 or around 0.25 Arweave tokens to store 1 gigabyte of data inside the Arweave ecosystem. And that's going to be distributed, that's going to be consensually open, and it's going to be in the permaweb. It's going to stay there forever. So if you want to become a node and connect to the Arweave network, you're going to have access to all this data people are constantly sharing. And it's really mind-blowing everything that you can do with the permaweb. You can store all kind of files. You can store binary files, you can store images, video, PDFs, JSON files, text files, anything at all. You can store anything that can be part of your computer, you can store it in Arweave. And right now, while the community is growing, it's really impressive to see all the usages of these. For example, right now the Arweave team started the Russia-Ukraine initiative, where we're storing all the data related to Ukraine and Russia, the current situation that's going on. And the reason why we want to do this is because we want to protect the data in the permaweb. As Sam Williams mentioned, founder of Arweave, we don't care whether that information is true or not. We just care about storing the data. And with the permaweb, we're going to let historians figure it out, because they're going to have access to this data. They're going to have access to this data that cannot be modified. They're going to have access to all this data that's immutable. So historians in the future can modify this. The permaweb is the evolution of the way we store data, just like we did with books, and just like the Egyptians did with paintings on rocks. Right now, humankind have the ability to store data and pass it to other generations and pass it over time without the risk of it being lost, without the risk of it being manipulated, which is a risk that existed until a few years back. You could modify books, you could modify anything, but you cannot modify the permaweb, or you cannot modify any blockchain, for instance. So the permaweb, dedicated to scale and to store data, makes possible a lot of things. It makes possible the transmission of the information through generations in an immutable way. But it also makes possible a new concept. It makes possible lazy smart contracts. And what is a lazy smart contract? A few things here. Smart contracts are usually, the way we think of smart contracts is not usually in a lazy way. So smart contracts in platforms like Ethereum or like Near or any other platform, any other blockchain that accepts smart contracts as a first-class citizen, it's all based on a global execution, a global machine, a global state. So whenever you send an interaction to the Ethereum network is gonna catch that interaction and it's gonna execute it, and it's gonna, all the nodes are gonna agree upon this result of that execution. Along with that execution, you have things like gas, you have things, different fees attached to the interaction that you're doing to the smart contract. And all these computers around the world execute the same code, execute the same interaction, which is the input of the smart contract, and agree upon the final state. And this happens every time the contract receives an interaction and there's consensual agreement on it. But this is all done not lazily, because you have all these computers, as I mentioned, working on that contract, actually executing that contract as soon as the contract receives a new interaction. As I mentioned before, with Arweave, you're able to store any kind of data, any file, anything at all, which means, and which opens the door to lazy evaluated smart contracts. And what is a lazy evaluated smart contract? Basically, the principle is, if you can save the source code of the smart contract in the permaweb, and you can save the interactions, the transactions that the smart contract is going to receive in the permaweb, you're going to be able to execute the contract and always get the same result. And why in the permaweb? Because the permaweb ensures the immutability of that source code. The permaweb ensures the immutability of those transactions that are being sent, and anyone can send interactions to the contract. With a few configurations, your contract gets readable. But you need some sort of execution machine. And that's why the Arweave team decided to create what's known as SmartWeave. SmartWeave is a standard, and it's an execution machine currently written in Node.js, which pulls all these interactions and which pulls the source code and executes the contract. With this concept, you can easily write contracts in any language, because as I mentioned, you can upload any kind of files. Right now, it is possible with SmartWeave, with Arweave, in SmartWeave to write contracts in JavaScript, which is something not so common. And it is possible to write it in a deterministic way, which means the same input is always going to lead to the same output of the contract, also known as the state. There have been a few inventions out there that make this possible, such as 3M, but I'll talk about it a little bit later. Right now, I want to focus on this concept of lazy evaluated contracts, with the principle that if your source code is stored in the blockchain and all your interactions are stored in the blockchain as well, then any person can run this smart contract in a secure way. Why? Because of determinism. Because the network ensures there's consensus on that source code and on those interactions, which means whenever an end user pulls all that through a software like SmartWeave or 3M, they're all gonna get the same output. They're all gonna get the same state. This is just because determinism and blockchain. Blockchain makes it immutable. Blockchain makes the source code of the contract immutable. Blockchain makes interactions of the contract immutable. And the executor, such as SmartWeave or 3M, just execute all, interpret all this source code, and that leads to lazy evaluated contracts, which means every time you want to run the contract, every time you want to reassure the contract is valid, you just need to load the executor, put your interaction, your contract ID, and the rest will be done by the software that's interpreting those interactions. And I'll show a few examples about it. 3M, on the other side, is a contract execution machine. And it's called 3M because it was meant to be known as the Web3 execution machine. 3M allows you to write a smart contract in different languages, such as Rust, JavaScript, C, C++, and we're looking forward to integrating more of them. As part of the core team of 3M, we've seen a lot of growth in this concept of lazy evaluated contracts, and we want to keep integrating new languages so we can onboard new communities. Oh, I almost forgot. With 3M, you can evaluate Solidity contracts. So 3M is actually capable of running contracts written in those 4 languages I just mentioned, plus Solidity, or anything that's compiled to Ethereum bytecode. 3M is capable of doing that. And the reason why we decided to structure it this way is because we wanted to do one thing. We wanted to onboard members of different communities, such as the Ethereum community or the Solana community with the Rust contracts that 3M is capable of running. We wanted to integrate all members from different backgrounds inside the Arweave ecosystem. And we're successfully doing so as 3M grows in usage. Many applications out there are already using lazy evaluated contracts. To name a few, Verto, which is a decentralized exchange that uses lazy evaluated contracts. And with the principles I mentioned, Verto is actually able to securely and in a decentralized way transfer tokens from one account to another account and so on. All done in a lazy way. No need for a global computer or thousands of computers evaluating the same contract, as Arweave ensures that the source code and interactions are going to be there. So you only need to worry about running it. With it said, we're going to go into some examples on how to achieve these behaviors. Now that we're back here with the examples, I want to go with this quick presentation of who I am and what I'm going to be talking about in the examples. And since we have a very limited time, I will try to not extend so much, and I will just try to cover what's important about Arweave and lazy evaluated contracts and everything that I talked before. So I'm Andres Pirela, as you know. This is an introduction to Arweave, 3M, and Verto. Who I am. I'm a software engineer. I love outdoor activities, skiing, running. I love animals, and I live in the state of Florida, sunny Florida, in the United States. I'm very passionate about software, and I've been an architect and consultant for Verto, which I'm gonna touch ground in the future as we go down the road. And in the open source community, I'm part of the core developers of 3M, which we'll see in more details soon. So what is Arweave? Arweave it's a decentralized blockchain-based storage, which is also known as a permaweb. So if you read about Arweave, you might find the word permaweb very common inside the Arweave context. And the reason why it's called the permaweb, it's because it allows any type of information, any type of data, any type of files to be served, and the nodes have the ability to serve this data as regular files in URLs. So you don't need to do something technical. You don't necessarily need to do something technical, such as downloading a node to access the information, but you can access with an URL that's going to serve the data in the way it's supposed to be served. So one quick example about Arweave being a decentralized storage is, as I said, you can store any type of data and nodes can actually serve the data. So for example, here we have this transaction that was sent and it has a content type tag. It's a tag. So transactions inside Arweave have the ability to contain tags, which is metadata. You can put anything in a tag, or you can have as many tags as you want. And one regular tag that we know is content type. So right now, this transaction, this ID of the transaction, and this some sort of block explorer, this transaction is a content type application PDF, which tells us this is a PDF that's being stored in Arweave, in the permaweb. So if I want to proceed and open it, I would do the following. And now this being redirected, this URL that I put here is being redirected to a node, and the node is actually serving this document. So it's not like it's being saved in Amazon storage or something like that. It's actually being saved somewhere in the world, in a computer, in a decentralized computer, in a node that's working for this decentralized network known as Arweave. And it gives you the ability to serve these files, and you can do this with pictures, with audio, and any type of files, or data. You can serve JSONs and so on. So if we go to this wallet has several transactions. I believe this is a JSON one. Let's try to find a JSON transaction. Oh gosh, they're all PDF. Okay. Okay, so here we have a JSON transaction. So the content type is application JSON. So if we repeat the same process now with this transaction ID, which I copied from here, we should be expecting a node to serve this JSON. And let's give it some seconds while it loads. And here we have we're getting JSON served from Arweave. So we're getting a JSON served in our browser from a decentralized computer, a decentralized blockchain network, Arweave. Now, moving on to a little bit of how can I upload a file, how can I upload content to Arweave. Well, there's different ways, and I won't extend so much in it. But there's applications out there. There's wallets that you can install in your browser as an extension, and you can actually upload a file. There's also Arweave.io, which is some sort of Google Drive, but backed by Arweave. So everything that you upload here is it goes to Arweave, and Arweave has a very competitive price. So with $9, which is the equivalent in AR, which is the native token of Arweave, with this amount of AR, which is $9, you can upload 1 gigabyte, and it has a very competitive price. It's not so expensive, and you only pay once. So after you upload a file, you only pay once for that file, and it's going to be stored forever in the permaweb. But I have an example here. A very straightforward example. I'm not uploading a file per se. I'm uploading a hello world, hello web3com. So here I'm importing this a Node.js file. Here I'm importing the Arweave package, and then I'm uploading it here, and then I'm reading from my wallet. I'm creating the transaction. I'm signing it, and then sending it to the network. So if I do this, I'm expecting this ID, and now we're gonna look for this ID inside the block explorer. We have from here, if I copy this ID and I go to arweave.net, which is the central, the gateway that interacts with nodes, and it's capable of serving this data to you. If I go here, which is the transaction we just posted with this content, we see we have a file downloaded, and if I open it, hello web3com. So that's with JavaScript. It's a very straightforward library, and you can upload any type of data, strings, JSON objects, buffers for binary files, images, PDF, whatever you want. And by adding tags, this way you can add, for example, content type, and then you would do application PDF if you're uploading a PDF. So the network is going to recognize
that piece of data as a PDF file. We know what's Arweave, decentralized storage. What are lazy validated contracts? Lazy validated contracts are basically you upload the source code to the permaweb, to Arweave, and interactions, and then with an executor, which can be any software that's able to interpret those interactions, those transactions, are going to be able to generate a result. So for example, here we have a contract, and this is in some sort of view explorer. Here we have the code, which is stored in Arweave. It's a JavaScript code. It's a smart contract written in JavaScript. Then here we have the transactions. The transactions are just JSON, as you can see here, the regular JSONs that you pass. And then you can read the state with tools like Arweave or 3M. So for example, it's loading all in the interactions, so it's pulling from the permaweb, it's pulling from Arweave, and it calculates the state. So it runs this code based on the transactions or the interactions that it's getting, and it generates a final state, which you can also see here. So that's a lazy validated contract, because Arweave is not computing, it's not doing any calculation to this contract, but you do it off-chain as a lazy evaluation. You only need to have the executor, which can be 3M or Arweave as the native project built around Arweave, and you can plug the ID and use it. As mentioned, some of the Arweave smart contract executors, since this is off-chain, lazy validated, are Arweave and 3M. But what is 3M? 3M is a fully deterministic, so unlike Arweave, which runs inside Node.js and a Node.js environment, it has a lot of security flags for the same reason, and you can use non-deterministic behavior. So 3M fixes all this by being fully deterministic. It's also secure, it's a sandbox, it has no access to syscall, so it's not like you can download a file and plug it inside the person that's running the contract. And it's multi-language, so it supports EVM languages such as Viper, Solidity, and it also supports Rust, SIG, AssemblyScript, C, C++, and JavaScript. It's blazingly fast. It's about 3 times faster than Arweave, and here we have a demonstration of what 3M looks like. So here I'm running this contract. I'm running this contract ID, which is the same one we run with Arweave, and now I'm gonna run it, and yep, here we have the state. So it's blazingly fast. It's way faster than Arweave, as you can see, and it has all these features such as fully determinism and secure and multi-language. And this one, I'd say this is one of the biggest features of 3M. Finally, I want to touch ground with what Verto is. Verto is a decentralized exchange that runs inside Arweave. So how does this work? Because Arweave doesn't support smart contracts per se, but it supports lazy validated contracts with off-chain executors, as shown before. So Verto actually makes use of lazy validated contracts and it powers a whole exchange where you can trade tokens, NFTs, and all those kind of things. So what I want to point out with this is that with lazy validated contracts you can have the same behavior, and you can have to some extent the same benefits of decentralized computers such as Ethereum, such as Solana, that are always running smart contracts. With lazy validated contracts you have a lot more flexibility, but you can accomplish the same, and this is very important to remark. On a last note, if you're interested to interact with Arweave, I highly suggest to check this package, arweave.js. It has all the information, and it's compatible with the browser in Node.js, and it has all the information about how you can interact with Arweave, send interactions, send transactions, sign transactions. It's very detailed and very useful. So this has been a little maybe rush introduction to Arweave, 3M, and Verto. Don't forget to follow me on my Twitter, which I'm always posting thinks about this ecosystem. And if you have any questions, please do reach out. I hope you enjoyed this presentation, and I'll see you next time. This was Arweave, 3M, and Verto, and most importantly, lazy validity contracts, a new concept to the Web3 ecosystem. Thank you so much.